Rational inequalities. We've learned how to solve several different types of inequalities. Rational inequalities are similar to solving polynomial inequalities. So we have two methods. We can solve by graphing or we can solve with a sign chart. And we're going to go through both types. When we solve rational functions by graphing, it's very familiar to us. We graph each expression on either side of the inequality as two separate equations or functions. Then we identify all of the points of intersection. So for example, we're going to solve 6 over x minus 1 minus 6 over x and determine where this function is greater than or equal to 1. So as we stated on the last slide, we are going to solve this rational inequality by entering the left-hand side as one function. So y1 is going to be 6 over x minus 1 minus 6 over x. And then our y2, or our second function that we put in there, is just y equals 1. So we can see it graphed in this -5 to 5 window for the x and y. And since this inequality asks for when this function is greater than or equal to 1, we're looking for where the function is above and also intersecting the line y equals 1. So the first intersection point is at -2, 1, and the other intersection point is at 3, 1. So we're within this interval from -2 to 3, including the endpoints because of the equal to, such that x cannot equal 0 and x cannot equal 1. Well, why is that the case? Well, the reason why x equals 0 and x equals 1 are not included is because that's where the rational function equals 0 in the denominator or is undefined. So because the function's undefined at x equals 0 and x equals 1, they are not included in this set. So another way to write this section of the graph is that x is contained in the interval from -2 to 0, including -2, in union with 0 to 1, in union with 1 to 3, where 3 is included. Now, if you notice, when we look at this graph, there's this gap in the middle here. So I have a feeling that our function's missing a piece in the coordinate plane. So let's zoom out of our graph to make sure that this is the correct solution. And if it's not, we can make a correction to it. Let's see what happens when we zoom out. So if we actually zoom out of our previous graph that we had, which only went from -5 to 5 in all directions, we see that there's a little piece of the graph that's missing. There's this tiny sliver that starts off at like -infinity, hugs x equals 1, and then comes to this point at 1/2 -24, and then it curves and goes right back down. So now this tells us that this middle interval from 0 to 1 that we originally had should not be included in our final solution set here, or interval set. And that's because from 0 to 1, it's not above the line y equals 1. So it should not be included in our answer. Therefore, the final set of numbers that satisfy the conditions of this inequality is x is contained in the interval, including -2 up to 0, not including 0, in union with 1, where we're not including 1, up to 3, where we are including 3.